For my video project, I'm going to be talking about potential and kinetic energy. This is geared towards a 6th grade science classroom, and it's just introducing the topic and going over the definitions with an example. So my students would need these worksheets from Google Classroom. If they were unable to print them out, they could follow along on just a piece of notebook paper, and they would need a pencil to write with. Now I'm going to switch over to me actually writing the notes, so my students would follow along with me as I am filling out these worksheets. And they don't need to write, but if they would like to, I had these resources up for them so they could follow along if need be. So our first definition is energy, and that is the ability of a system to do work. So energy is required for changes to happen. So over here you can see that this light bulb had no energy, and then when it was given energy, it was able to turn on. Our next definition is potential energy. So this is energy that is stored in the system or an object. So in our picture over here, we have a ball that is at the top of the hill, and it has stored energy because it is not moving. This stored energy turns into kinetic energy, which is the energy of motion. So now we can see that our ball moved down the hill and it transferred from potential energy to kinetic energy. And this is because of the energy transformation. So it is the change of energy from one type to another. So in this example over here, we have that the light is getting electrical energy, so it was plugged in. Before it was plugged in, it had potential energy, and then as it was plugged in, it moved to the electrical energy, letting it shine the light. So now that we know about potential and kinetic energy and the energy transformation, we can take those and put them into a roller coaster example. So we're going to determine how much kinetic and potential energy each roller coaster cart has at each of the 3 stops. And then we'll talk about this term mechanical energy. So first we're going to look over here. So these girls are at the top of a hill. How much potential and kinetic energy do you think they are going to have? I'll give you a minute to think. So we know that potential energy means that it is stored energy, and kinetic energy is moving energy. So these girls are at the top of a hill, which means they're not moving, which means that our potential energy is going to be at the maximum, so it's going to be the highest, whereas the kinetic energy is going to be at the minimum or lowest because they're not moving. But now we can see, I drew these arrows in, and the girls are now moving down this hill. So do we think the potential and kinetic energy are going to change or stay the same? I'll give you a moment to think. So because these girls were moving down the hill, all of that stored energy or potential energy was transferred to kinetic energy because they were in motion. So now our arrows are going back up the hill. And now one last time, what do you think is going to happen to this kinetic and potential energy? Is it going to stay the same as it was down the hill or change? I'll give you a moment to think. So because these girls are moving up the hill, what happens when you move up a hill? Do you continue to go faster or do you slow down? You slow down because you are gaining or losing your speed. So this means that the potential energy is going to go back to being at the maximum and the kinetic energy is going to be at the minimum, similar to over here. So you are switching between the two based on if you are moving or not moving. So this leads us back to the mechanical energy. So as you can see in the 3 points, you had both potential and kinetic energy. One was just higher or lower than the other. So that means that the total amount of mechanical energy, which is just the potential and kinetic energy combined, is the same at every location. So energy cannot be destroyed, it can only be created. So the potential and kinetic energy are changing, but it is never going away. So we can say that this mechanical energy is equal to the kinetic and potential energy, like this equation here. And we know that based on this example, that the mechanical energy is staying the same and our potential and kinetic energy are varying. Now we're going to move on to some questions just to kind of check your knowledge based on the notes we just went over. So, what is stored energy? Pause the video at the end of every question to kind of think, and then we'll go over the answer. So, our stored energy is potential energy because it's not moving, it's storing its energy. What is energy of motion? Again, pause the video. This is our kinetic energy because it has transformed from potential to kinetic because it's moving. If a student is about to drop the ball has which kind of potential or kinetic energy, or both? It has potential energy because the ball is not moving yet, but it is storing energy so it can move. When a roller coaster car is at the top of the hill, it has high potential energy and low kinetic energy, high potential energy and high kinetic energy, or low potential energy and low kinetic energy. It has high potential energy and low kinetic energy because remember, just before we were looking at that roller coaster example, when a roller coaster is at the top of a hill, it's not moving and it's storing its potential energy, so as it goes down the hill, it will gain kinetic energy. Which of the following changes will increase the kinetic energy of a snowball that's at the top of the hill? Would melting the snowball increase it, adding snow to the snowball, or pushing the snowball down the hill? It would be pushing the snowball down the hill because remember, kinetic energy is the energy of motion, and melting the snowball isn't making it move, and adding snow to the snowball isn't making it move. But pushing it down the hill is moving that snowball, so it is increasing the kinetic energy. And our last question is, when would a marble have the most potential energy? At the top of a ramp, at the bottom of a ramp, or while rolling down the ramp? It would be at the top of the ramp because remember, in our roller coaster example, it is at the top of a hill or the ramp and it's storing that potential energy, so then it has the kinetic energy to move down the hill when it's in motion.